Hello students, welcome to my channel. In this video I will discuss a question from the modern physics topic based on the nuclear forces. The question as follows. From the statements given below, you need to identify the correct answer. So in this question there are five statements A, B, C, D, E. So we need to identify which is correct in this statement. The question: the angular momentum of electron in nth orbit is integral multiple of h. Yes, it is correct. One of the Bohr's postulate. The magnitude of angular momentum is equal to integer multiples of h by 2 pi, where n generally called as a principal quantum number. Okay, this is correct. A correct. So that means this can't be possible. Next, nuclear forces do not obey inverse square law. Obviously, they will not obey the inverse square law. Okay, so inverse square law generally obeyed by gravitational force, electrostatic force, magnetostatic force. Two magnetic poles separated by some distance, then the force is 1 by r square. But nuclear forces does not obey the inverse square law force. Generally the nuclear forces, if I talk about the potential, nuclear potential is some constant multiples of e power some constant multiple of r divided by r. Okay, like this they depend. So that means B is also correct. That does not obey inverse square law. Next, nuclear forces are spin dependent. Yes, it is correct. Nuclear forces are spin dependent. Next, nuclear forces are central and charge independent. Charge independent is the one of the property of nuclear forces because this acts between proton-proton, neutron-neutron, even and proton-neutron. So from here we can conclude that they are charge independent. But the forces are central is the wrong. They are non-central forces. So what is the meaning of non-central here? If they are central, then angular momentum is conserved. L is conserved quantity for central. For non-central, L is not conserved. So it is found that for nucleons, angular momentum is not conserved. That's why they are non-central in nature. Stability of the nucleus is inversely proportional to value of packing fraction. Yes, this is also correct. So here D is the wrong option. So stability of the nucleus is decided by the packing fraction or binding energy, you can say. How will define the packing fraction? So the packing fraction is defined as m minus a divided by a. Here a is the actual mass number. Actual mass number. Here m is the mass number. It is simply the mass number. So A is obviously it is the sum of the number of neutrons plus number of neutrons. M is the mass of that element. That you can take that element, put in a weighing machine and measure it. That is the measured mass, you can say. So definitely P can be positive, P can be negative. Suppose if I say P will be negative. What is the meaning of negative? M minus A is negative. M is smaller than that of A. So M is smaller than that of A. That means there is some mass defect will be there. Some positive value. Some mass defect is there in the sense there is some binding energy, that delta M into C square. So this delta M into C square will hold the nucleons together, that way stability. So packing fraction negative indicates the stability. So similarly packing fraction positive indicates the unstable. So for a P negative, the stability will be there, more stable elements. For P positive, So for P positive, they are unstable. So that's why stability of the nucleus is inversely proportional to the value of packing fraction. Less is the packing fraction, more is the stability. So excluding the D option, all are correct. Even in the D option, if there is no central word, then that is also correct. So A, B, C, E are correct in the given situation. So what is correct in the D problem is nuclear forces are non-central in nature. Okay, be careful. I hope it is clear, and this is one of the important concepts, the properties of the nuclear forces. Try to remember the concepts. I hope it is clear. Thank you. Thank you for watching my video. Please subscribe my channel. Don't forget like and share.